shit. Why are you so close to my face? Is it on?
Yeah, it's on.
Okay. In this journey through controls, we will take a closer look at the dynamics of a climber rappelling off of a cliff.
The components of the system are the anchor highlighted in orange, the climber's hands highlighted in blue, the rappelling device highlighted in green, and the rope highlighted in red, along with the mass and the wall labeled in pink. The frames at play in this system are the earth inertial frame highlighted in blue and the climber's frame highlighted in green.
These are the equations of motion that govern our system, as represented in the climber's frame of reference. Theta is the angle of rotation about the z-axis between the earth inertial frame and the climber's frame, F sub F is the force of friction applied by the climber, and N represents the normal force against the climber's feet.
The input to the system is theta, which is the angle between the two reference frames, and the output to the system is the climber's arm position, which then in turn changes the force of friction. This system is continuous because theta is always changing at some rate.
Note here that on the low-angle wall, there is less frictional force needed, so the climber's hands are farther away from his body.
Okay. Note here that as the climber moves from low angle to high angle, more friction is needed, so the climber's hands move closer to his body.
The control law governing this system is a PID controller. The performance metrics relevant to this system are peak response, because this represents how quick and aggressive your response is, steady state error, because this represents how smooth your steady state behavior is, and settling time, which represents how long it takes to get to steady state. Additionally, the feedback for this system is positive, because as the input, theta, increases, the frictional force applied by the climber also increases. Here is the block diagram for our system.
This is an example of a climber with high peak response, low steady state error, and low settling time.
My elbow isn't it?
In this case, the peak response is still relatively high, however the steady state error and time to settle are much higher.
Thanks for watching!